Right. Hello, everybody. Welcome to the Yueh Anglo-Japanese Foundation. My name is Jason James. Right. Well, we're kind of all over the place today. So as I mentioned, I'm in Cambridge and we have our panelists joining us from Germany, South Korea, and London. And I'll just very briefly introduce them before we start. So Akira Igata is a project lecturer at the Research Center for Advanced Science and Technology in Tokyo. And he is a fellow at various other bodies, including the Interparliamentary Alliance on China, and advises the Japanese government, primarily on security-related issues. And then joining us from Germany, Jan-Peter Kleinhans, is head of the technology and geopolitics topic area at Stiftung Neue Verantwortung, and he is a semiconductor specialist. So that's our topic today. And he also advises the German government and has presented to the NATO Parliamentary Assembly as well. And then our moderator today is Linda Yueh. She is an academic economist and author. She's fellow in economics at St Edmund Hall in Oxford and an adjunct professor of economics at the London Business School. And she's published a number of books. And in fact, the latest was out, I think, just last week, The Great Crashes, Lessons from Global Meltdowns and How to Prevent Them. So on that note, I'm going to hand over to Linda to chair it. And here is the timeline we are looking at. So about 25 minutes of panel discussion and then 20 minutes or so of Q&A. So over to you, Linda.
Thank you very much, Jason. And thanks very much to the lovely team at the Yueh Foundation for organizing what I'm sure is going to be a very stimulating panel. I know whenever somebody tunes into a webinar, they say, oh, this is a hot topic, but this is a hot topic, the global chip war. And we're very lucky to have two terrific panelists. So as you saw from the schedule, I'm going to lead them in conversation, and then there'll be about 20 minutes for Q&A, which we very much welcome and would love to hear from you. So please do everything that Jason said to participate. Raise your hand, put your question in the chat if you'd rather for me to ask it, and raise your virtual hand if you want to ask it yourself. So with that, I'm going to kick off. So the very first question that I want to pose to the panelists, just to give us a sense of this global chip war. And Akira, I'll come to you first. What was the cause, to the extent that you can explain it to us? And then I want to move on to a bit about the future implications for the semiconductor industry. But let's just start with the cause. And then, Jan-Peter, I'll pose the same question to you.
Fantastic. So how long do we have? I guess I can keep on talking about this question for like 2 hours, but I'll keep it very short. First of all, thank you so much to the Yueh Foundation for inviting me. I'm actually in Jeju, South Korea, Hawaii of South Korea. And there's actually a couple different musicals going on outside. So if you hear, songs of Tomorrow from Annie or Little Mermaid or something like that, then my apologies. I'll try and keep my self muted most of the time, as long as I'm not speaking. And so with regard to the causes of this chip war, if we are to call it that, there are, of course, numerous reasons for it, but I would pick out two. One, security-oriented factors, and two, economic-oriented factors. And the first military-oriented factor is probably the one that's mostly focused in the popular media these days. And that logic is basically that because we can't let certain countries have the most advanced semiconductor chips, as they can be used for the modernization of those forces, namely China, it makes sense for US and its allies and partners to try and curtail some of its exports of semiconductor manufacturing equipment to China. And of course, this makes sense, but I feel like there's also a less talked about economic aspect to this, which is that if you look at the short-term implications of all of this SME, semiconductor manufacturing equipment export controls, then of course, the Americans, the Japanese, the Dutch, these companies are going to be losing sales. So this seems like bad. It's bad for the economy of these companies. But then if you look at it look at this from the long term, then it might actually make more sense to engage in these kind of economic export control against China for the following reasons. Over the past couple of years, we have seen cases in different industries. The most easiest case would probably be the solar panels, where the Chinese government subsidized many of the Chinese companies. And with that, what ended up happening is different countries would make things in China, would transfer their technologies to China, and then China would come up with the most high-end, high-quality products, which is subsidized by the Chinese government. And then this very high-quality product would be dumped onto the global market, and no other companies can compete anymore. So the Chinese dominate the market, and now we are newly reliant on China for solar panels. I think the same logic can be made for high-end semiconductor as well. And because of this military and economic reasons, I think that we are now seeing this a flurry of export controls against China and against the US recently with the micron restrictions regarding high-end semiconductor chips.
Thank you very much, Akira. Very succinct and informative. So thank you very much for that. Jan-Peter, I could see you nodding there. It'd be good to hear from you about the causes of this global chip war.
Thanks, Linda, and also thank you from my side for having me. I would actually try to pick up where Akila left, because I would totally agree that right now it is sort of a conflated debate where sometimes we talk about hard national security questions. Then at times it is about economic security that is linked to national security, but often it is also about plain and simple protectionism and industrial policy. And I think the reason for that is that governments in recent years, and I would say this is maybe true for the last 5 years or so, have realized that obviously for digitalization in society and industry, semiconductors are the foundational technology. So if some of you, or hopefully all of you, played around by now with things such as ChatGPT and generative AI, you realize that none of that would be possible without high performance AI accelerators, mainly from NVIDIA in the US and AMD in the US. But the thing is that these general purpose machine learning algorithms deployed on commercial general purpose chips can be utilized for military activities. And for me, and Akila mentioned that the October controls from the US government, for me, this is really one of the striking things about the October controls from the US government, that the reasoning from the US government is relatively simple. They say, because of military fusion in China, and I'm quoting here, I'm not saying that this is my perception, but just the reasoning from the US government is because of civil military fusion in China and the general purpose nature of foundational technologies such as machine learning and semiconductors, whoever has the better compute infrastructure, so whoever has more chips and more performant chips in their own jurisdiction, has per se a strategic and kinetic advantage in the next war, no matter when that happens. But whoever has better computing resources to plan, simulate, and analyze the next war with the help of machine learning has a strategic advantage in the battlefield. And because of that, at any point in time, the US now wants China to have an inferior compute infrastructure than is available in the US. So at that point, suddenly, it doesn't matter if the general purpose AI chip is deployed at Baidu and Tencent and Alibaba for a commercial cloud, because the assumption is simply that this is compute infrastructure in China that is available ultimately to anybody in China, including the military. And that's what we do not want. The think tanker, the intellectual in me likes this assessment because it is very honest. The problem is that it is extremely hard to implement that based on export controls, because as Aquila mentioned, essentially you talk about a vast majority of commercial applications that will be and that are impacted by those controls. And since generative AI is a general purpose technology for every industry, for every sector, if you do not have access to the latest and greatest of general purpose AI, you will have a competitive disadvantage in the commercial field because of national security considerations in the military realm. And that makes the field so tricky, right? Because ultimately you need to restrict things in the commercial realm when actually you are worried about the national realm. And in between, you can easily inject protectionist measures that are actually not at all about hard national security, but you can sell it under the umbrella term of national security, because you can always make that argument.
Thank you very much. And I think your comments actually lead to the second part of my opening question to both of you is, what are the implications then for the future of the semiconductor industry, which is, as you both have articulated, so very important for generative AI and AI, which is already here. And those of you who haven't played around with ChatGPT, if you don't know how to code, but you'd always wondered if you could do a bit of code to do something, it will write the code for you. I would just leave that there. Akira, what are the implications for the future of the semiconductor industry of this chip war?
Sure. So just before answering that question, I wanted to pin a great book that just came out about 2 or 3 months ago, written by a guy named Paul Shar from CNAS, Center for New American Security. And he came up with a book called 4 Battlegrounds. And it talks about how AI changes everything from military relations to disinformation to economic prosperity and so on. And it's a really easy to read book. So if any of you were really interested in learning more about AI but has no idea what AI is or why it's important, then please pick up this book. I'm not being paid to say this. I just think it's a great book. Now, what are the implications of all of this new global chip war to the companies? I think it poses both opportunities and challenges. I'll start with the challenges because it's easier to see. Because countries are now engaging in new export controls and investment screening, and now to some extent visa controls for the technicians who can try and fix some of these semiconductor manufacturing equipment when they get broken down and so on, it's going to be very difficult for companies to expand into foreign markets, especially if those markets tend to be authoritarian in nature. Having that said, I think there are also opportunities here. Because if you look at the semiconductor value chains, it's global. And partial decoupling, de-risking, I guess, is sorry, I just had to okay. So de-risking seems to be the phrase of the days these days, but it might be possible to partially decouple the most advanced semiconductor supply chains from a single country or two, but it would be impossible to reshore everything in its own countries. So now you see different governments engaging in various modes of subsidies, from the US in the CHIPS Act to Japan's new law to EU to South Korea announcing, what was it, like a $30 billion-ish investment in the next coming couple of years and so on. Singapore, there's lots of investments going on. India has announced all of this. So the companies which were not able to compete with China in certain areas now has the opportunities to use this subsidy and become from number 2 to number 1. So in a way, whenever something changes, then there's always going to be challenges and opportunities. But I think that if the companies are smart, there are ways for them to try and utilize this opportunity to revive their industries and economies in the semiconductor field. And Japan is probably the prime example of this. The Ministry of Economy has been engaging in different sorts of policies, creating new laws, and giving lots of different subsidies for the semiconductor industry. You have the Taiwanese company bringing in 2 of their factories to Kumamoto for more of the legacy chips. You have the new company called Rapidus, which is now creating a factory in Hokkaido in order to create a 2-nanometer state-of-the-art semiconductor chips in conjunction with US IBM and European IMEC. And it's the government that's really funding all of this. Of course, the goal here is to try and get private capital involved by investing in all of these projects through using taxpayers' money. But we haven't seen that yet. But my guess is that as long as this continues and the Japanese private sector sees that this isn't just a one-off thing and that the Japanese government is going to be subsidizing this for the next couple of years, then I wouldn't be surprised if we start seeing more private capital going into the Japanese semiconductor industry, and perhaps that could lead to the revival of the Japanese semiconductor industry.
Thank you. Same question to you, Jan-Peter. What are the implications for the semiconductor industry?
Yeah, I'm also wondering. I mean, I would partially agree regarding the opportunity for certain regions to gain or to rejuvenate their semiconductor ecosystem. But I also see a few challenges. So first, maybe with the exception of the US, really, so far from most governments, the focus has been overly on a very specific process step, which is front-end manufacturing, wafer fabrication. This is getting huge subsidies because it's the, in terms of capital expenditures, it's the most intensive process step. So everybody now cares about who builds a fab where. The challenge that I see here is that this is just one out of several process steps. So for example, where we see very little investment is in back-end manufacturing. So the following process steps of assembly, test, and packaging. Very few announcements, very few, at least for Europe, I can say that very few government attention and also thus subsidy attention. And the same goes for the process step before wafer fabrication, which is chip design. And here the exception is really the US and to some extent also the UK. Because they explicitly mention the importance of also investing in chip design in their strategies. I would say that the US CHIPS Act puts money behind it. With the EU CHIPS Act, of course, if you read through the 70-page document, you will also read about chip design and the importance of chip design. But then if you just put together where the actual subsidies are flowing right now, I would say 95% of the subsidies are going toward front-end manufacturing. And I think in the long term, governments should care at least as much about who and where develops a chip than just about the question where and who are chips being manufactured. Right? Like there's right now this crazy amount of attention on TSMC, rightfully so, for many good reasons. But the reality is,
the Taiwanese chip maker.
Yeah, exactly. Sorry. So the leading chip contract manufacturer in the world, and at the moment the company with the most cutting edge manufacturing process. But I think it's always important when we talk about TSMC to use the phrase contract manufacturer or foundry, because TSMC does not develop a single chip by itself. It manufactures the chips that have been designed by Apple, that have been designed by Infineon, that have been designed by NVIDIA. And there's value in that. There's value in contract manufacturing, and it is, of course, an important process step. But I think, at least currently, there's an overemphasis, in my opinion, from governments on the importance of one particular process step, front-end manufacturing, and they underappreciate the complexity of the value chain, and that in the long term, it would need attention on all different process steps if your ultimate goal is really to become less reliant. Because to make it concrete, how much did it decrease your reliance, or how much did it increase your autonomy if now 10 or 20% of front-end manufacturing happens in your own country, but then when the wafer is finished, this wafer is shipped to a foreign country for the following process steps, which are assembly, test, and packaging. And once that chip is then finally done, the chip most likely is shipped to China for final assembly and soldering in it on the printed circuit board to finalize the whole product. So right now, I feel the focus from government is a little bit skewed, that it is an overly emphasized the importance of manufacture of a particular manufacturing step, and then underappreciation of the interconnection and the interdependency within the supply chain.
Yeah, both of your points are really interesting. And I think the next question I'm going to ask you is actually to draw us a little bit more about the impact of this chip war. And let's focus on Asia, please. I mean, immediately from what you've said, I'm an economist, so I'm naturally going to be using terms like subsidizing perhaps will distort the focus onto chip manufacturing rather than the other bits, including R&D, which has been absolutely essential in terms of chip advances, displacement of supply chains because of potential trade restrictions, export controls. And I mean, for what it's worth, I think we do live in an era in which commercial decisions like supply chains, not just in this area, but in other areas, will be affected by geoeconomic tension. So this is just one example. But all of these things introduce frictions. They make commercial decisions more challenging because of the uncertainty it introduces by the various policies of different governments, which sometimes compete and sometimes are in cooperation, but certainly not across the world. So if I look worried, I am worried, especially given how fundamental chips are. So Akira, please share with us, some of how you see the impact of this playing out in Asia.
Sure. So I think if this global chip war devolves into a global subsidy war for semiconductors, then nobody in Asia wins, right? I talked about all of these subsidies being done in many of the major Asian countries, including Japan, South Korea, Singapore, Taiwan, and of course now China. If you look at not just Asia, but the Indo-Pacific, then of course US joins the fray. And depending on how far you would see the Indo-Pacific concept, then it could be extended to other countries as well. So in order to control some of this, or to make sure that not everyone loses out, I think a minimum level of coordination among countries are going to be necessary. However, if you coordinate too much, then how would that be different from an international cartel in a way, right? So I think countries need to find the right balance, the Goldilocks balance between this collaboration and coordination. And I actually don't have a good answer to it. And my guess is that the government in the aforementioned countries don't have the right answers to the right answers to this as well, and that's why you're now seeing this proliferation of minilaterals or multilaterals in Asia, all purporting to work on either semiconductor cooperation or supply chain cooperation. For example, the Japan-US bilateral agreements have various aspects of semiconductor cooperation. There is the new Chip 4 or the Fab 4 between Japan, US, Taiwan, and South Korea that's supposed to be working on this semiconductor coordination, but I'm not sure where that's going. We recently saw a trilateral coordinated export control on semiconductor manufacturing equipment between Japan, US, and the Netherlands. But I'm not really sure if that's the one-shot trilateral coordination, or if it's going to continue on engaging in similar regulation once the technology advances. There's the Indo-Pacific Economic Framework, IPEF. There's AUKUS. There's the G7. There's just so many new and existing minilateral. Becoming the forum for discussing on this collaboration and coordination on semiconductor issues. And to be honest, I don't know what the right venue is, but the countries, I think, needs to figure out where that's going to be very soon.
Wow, proliferation of acronyms, just what we need in world trade and world affairs. Jan Petersen, question for you.
Yeah. I think time will really tell if I feel increasingly that we are in this time of experimentation. There's a certain level of activism from governments across the globe to do something in semiconductors. And the tools that they are used to and the tools that they know how to deploy, export controls, foreign direct investment screening, sanctions, they realize that these are highly disruptive in this interconnected value chain, and they work. Ultimately, no matter if you like it or not, they work. Of course, you might need a few iterations of your export control until you get it right. But for example, if we just look at the declining sales of Huawei, you can make the case that US export controls against Huawei have worked. They are disruptive. But beyond that, now, as Akila mentioned, governments talk about strengthening supply chain resilience, cooperating for strategic investments. I have a big question mark in the long term if this is actually money well spent. Does it make sense for governments to be technology pickers, to decide, hypothetically, Intel's manufacturing right now has more prospectors than Samsung's manufacturing, so I will subsidize the Intel fab instead of the Samsung fab. Or as another example, the UK strategy explicitly mentions the importance of compound semiconductors. So semiconductors that are not just made out of silicon, but for example, are made out of gallium nitride or silicon carbide, so two materials with different physical characteristics. There are good reasons for that. It's an interesting technology, and it's already commercialized and deployed since many years in many different areas. And there's still a lot of research to be done, but I'm still wondering, is it smart for a government to pick and to say, look, this is where we think we should go? Because ultimately, that's what, for example, venture capital is doing, and venture capital is often wrong. Venture capital doesn't have a perfect. You pick the wrong technology, and I would say also in terms of semiconductor efforts, there is a history where governments simply bet on the wrong horse. But if we now do that on scale, if we now talk about hundreds of billions of US dollars in subsidies globally that are poured into the sector, I think there will be waste. There will be not 3 years from now, or not 5 wrong. That was not money spent smart. And in terms of cooperation, I agree with Akila. There is right now an influx of bilateral and multilateral forums who all want to do something in semiconductors. But I truly hope that governments will take the time and do their homework to figure out in which areas they can actually have a positive net impact. I think there are fewer than right now are on paper. For example, I don't think it would work that governments talk about strategic investments and aligning strategic investments, because ultimately no government will ever say, I'm not interested in that company, you can have that investment. I will take these two and you can have those three. That's fine by me. I don't need that. I don't need that workers. I don't need that jobs. You can have those jobs. I don't think that's a realistic. Yeah, I don't think that's a realistic estimate. So I'm just curious. 5-10 years from now on, will there be a chips 4? Will there be a working group in G7 doubling down on semiconductors? Will there be an interministerial meeting in the IPEF on a regular basis, just talking about chips? Or will it quiet down? My bets are on the latter.
Thank you very much, Jan Peter. So in terms of VCs, venture capitalists, and their bets in the United States, the success rate on the startups that VCs have funded, so this doesn't include all of the startups that were rejected, just the ones that are funded every year, the success rate is no better than a flip of a coin. It's a 50% success rate. And these are people whose role it is to allocate capital to fund innovation technology. So, so it's a very good point as to whether or not governments will be able to beat that coin toss. I guess on the other side, it is no better than a coin toss. They could have a go, which sounds like that's roughly what we're headed to. Before we open up to questions from the audience, I'm going to ask a rather unfair question of our two excellent panelists. And since we're mixing it up, I'm going to go to you, Jan Peter, first, which is, if you were in charge of, I was about to say the world, but why don't we say Germany? If you were the Chancellor of Germany, what would you do, given everything that we said?
I love that question. Thank you very much. Because thankfully, I'm not in charge, so it's very easy to talk about what other people should do. But to your question, my background is in computer science, so I always like to structure things. That feels natural to me. So if I structure the current debate about semiconductors, I'm always coming back to the fact that as policymakers, one should differentiate between the ultimate policy goal. Is the ultimate policy goal strengthening the competitiveness of your semiconductor companies? Option 1. Is your policy goal ensuring national security? Or is your policy goal ensuring security of supply for your end customer industries? So the consumers of or the customers of semiconductor companies. So the BMW and the Volkswagen and so on in Germany and Europe, who buy chips on the global market. Depending on your answer, your strategy will differ. So for example, if you are worried about security of supply, don't look at the semiconductor supply chain. Investing in fabs, in domestic fabs, does not help you with security of supply at all. If you're worried about security of supply, you have to look to the responsibility of the end customer industries. So you have to ask Volkswagen and BMW, what about just-in-time delivery? Can we please move away from that? What about strategic overstocks? What about long-term supplier agreements? What about dedicated manufacturing capacity that is reserved for you, that you pay in prepayments, and so on? Many strategies, none of them implemented currently on the regulatory level. If you're worried about national security, you have to accept that you will not bring everything back to your own jurisdiction, and you will only bring back a sliver of the whole supply chain back to your own jurisdiction. So who can you trust out there? On which other countries can you rely to manufacture and co-design and co-develop chips that are critical for your national security? And there you also have to accept that as a smaller country, you need a bigger circle of friends, because you will rely more on offshored or outsourced manufacturing and design than others. If it's about technological competitiveness, I think it needs to be twofold. That one, you strengthen the competitiveness of your incumbents. So as an example, in Europe, I think Europe would do well to ensure that 10, 20 years from now on, ASML still plays an indispensable role, that the Dutch equipment manufacturing company, that 10, 20 years from now, and ASML still plays an indispensable role to the broader semiconductor supply chain, because this creates geopolitical leverage. To put it frankly, ASML is the only reason why the US government approaches the Dutch government to talk about export controls. There is no other reason. You want to have, as a government, you want to have this leverage. You want to make sure that you have a seat at the table, because in certain supply chains, nobody can go around your own companies. But at the same time, those companies can make wrong decisions in the long term and can miss technology trends. So you also want to foster a startup ecosystem, and you also want to make sure that there are fledgling endeavors of smaller companies who might be right about future technology 10, 20 years from now on. That's at least my very structured view. I think reality is much more messy, but at least in theory, I would try to approach it that way, to be very clear, what is your ultimate policy goal?
Fantastic, thank you. Same question to you, Akira. If you were in charge, if the Prime Minister of Japan, what would you do?
Sure. Before answering that question, I want to quickly leave you two and the audience with, I guess, a food for thought on whether the government can play a venture capitalist role. While I think it's probably best to leave it to the private sector, there's an interesting exception, right? There's a company called In-Q-Tel, which is a venture arm of the US CIA. And they have been performing much better than the average private sector venture capital in the past. So maybe there's a way for the government to get it right. I'm not sure if that's a semiconductor, but that's just a food for thought. With regards to what I would do if I could control Japan's semiconductor policies, I would change two things. One, like I said, different countries are now investing so much in this semiconductor field, and so many new fabs are being created, so many new R&D centers are being created, and all of this money is being spent at the moment, I think, on creating, big factories and buying land and all of that. But, engineers and scientists don't grow on trees, right? If with all of this new investment, we need to have these new labor force. And at the moment, I think that the Japanese government is spending too much on the hardware of things and not too much on the actual talent development. So I would like to see more investment go into universities, perhaps creating a public-private, not public-private, the company and university relation alliances to create courses for nurturing and creating new talent in the field of semiconductors, so that after 2 or 3 years, these new graduate students could go into these new semiconductor companies and play a critical role in the industry. So I would invest more in people. And second, I would hold off on the public investment until we get more private sector money involved. By that, what I mean is, if you look at Rapidus, the 2-nanometer high-end semiconductor chip project, you have 8 major Japanese companies already investing in Rapidus, from Toyota to Denso, Sony, NTT, NEC, SoftBank, Kioxia, Mitsubishi UFJ. These are major champions in each of their own industrial field, and all of these 8 companies are supposedly investing into the success of Rapidus. But the amount that they are investing at the moment is a mere couple $1 million each. And METI, the Japanese government, is putting in a way more investment. And I feel like if this is to succeed, then the private sector should invest more in advance. But the government is going full in without waiting for the private sector capital to go in. So once again, if I was the foreign minister for economy, I guess, then I would hold off on the public funding for now and try and get more private capitals involved.
Great. Thank you very much. Kind of makes you wish both of you were in charge, actually, given your answers. I'm going to take audience questions now, but just as a matter of definition, we heard there about 2 nanometers, currently chips, 3, 5, we're talking kind of, so what is a nanometer? So a nanometer is 1 billionth of a meter. An average hair strand of hair is 60,000 nanometers thick. So we are talking about tiny, tiny measurements. So there we go, the trivia fact for the day for the dinner parties everybody will go to later on. So in a normal setting, we would be giving you two a huge resounding round of applause. I can see Jason there using his applause because you have both just been, as I can see the comments in the chat saying, you have been clear, you have been informative, you have had a rich and gave us an excellent debate and discussion. So on behalf of the Dawa Foundation, thank you both for taking the time and sharing your insights on this hugely important topic. And let me just also thank the lovely organizers and Jason there introing the session, putting it together, and just a wonderful team. So thank you all. And this will be on YouTube, so you can watch it all again very soon. So thank you all. Have a great rest of the day.
Thank you, Linda. Thank you all.
Thank you. Take care.
Bye-bye.